welcome to the August meeting. And again, we have a program change. Our presenter is sick and his son's gonna fill in with, what's it again?
Laura.
Oh, Laura's gonna fill in. And it's gonna be a different program. She'll announce that. I think, what did you say it was? It's gonna be atmospheric optics.
Yeah.
So a second change in the last couple of meetings. So we'll see what happens. So there's Joe. Welcome to everybody. I do have an announcement. I just found out that John Thomas has passed away on the 7th at midnight. And this is first, a lot of us have heard of it. So I don't have any other information than that. So any observing reports? Sorry, I'm having a little trouble with the mouth tonight. Anybody have any news or observing reports? Anything else to bring up?
You get some progress on the spectrograph front. It looks like tracking is probably under control. The guiding is under control. So that's nice. I had the last time out, I had guiding that had a total error of around 1 arcsecond. So not too bad. So we're on track to be able to get longer exposures and more consistent exposures. So that's a good thing.
Very good. What did you do?
When?
What did you?
Well, what did I?
For your improvement? Do you know?
Yeah, you have to have the scope properly balanced. That's
Okay.
the first thing. You have to have pH2 calibrated properly. And those are the two major things. I think I remember.
Were you guiding?
Auto guiding.
That's
So some fundamental stuff, and a lot of PhD2 exploration. We're going into that, but probably get them down the road on that.
Excellent.
So real close.
Excellent. Yeah, you're getting smart at all this stuff.
Yeah.
Won't be able to get your t-shirts on over your head.
It's getting out, so
Yeah,
that's right.
great. And I guess last Saturday we got rain, it was raining, right? And the observatory was called off again. So Mother Nature sticks her finger in our eye again.
Saturday doesn't look much better.
Yeah. Okay. Anything else before we go to the?
Yeah, just real quick. We had a meeting over Zoom of the outreach committee.
Yeah.
And I think we had two things. My brain is failing me, but one of the things was people said, "Hey, can we go somewhere and do something, see something cool?" There was some interest in going to the dark sky site, and actually the dark sky site that's about 2 hours away from Fort Wayne. That was the land was donated by a physician, Dr. Wallace, back in the 70s or something. But anyways, it's up there in Lower Michigan. And I haven't looked at the particulars, but basically there's a large observing field and it's certified as an international dark sky site. And it's next to, I don't know, Camp Takawanda or something, I don't know, some campfire thing. And so we might be able to snag a cabin unless you guys wanted to just tent out in the field or something like that. But,
Yeah.
So I'll just shoot some information that I gather around by email chain or something. But I mean, September, October is probably likely dates. I don't feel like freezing in December. So
A good old field trip.
yeah, I mean,
Yeah. Bring some new activities on board to get the club moving again. Yeah. Yeah, we've been talking about a few activities to kind of spur things on a little bit. So keep posted. All right. What do you, everybody ready for the substitute program or anything else?
No.
All right.
yes.
So what do you say?
She's got a history of presenting the farther away.
Okay. Well, Laura. Uh-oh, she's talking. Laura, you want to come up? And you've done a lot of presentations, and I'm sure this one will be as up to par as usual.
Okay. We'll get this show on the road.
All righty. So you're in there, and here's your presentation. It's
Okay.
ready for you.
Okay, very good. Okay, welcome. Glad to see everybody in person. I think this is
Center yourself with the camera.
oh, sorry.
You don't move
Okay.
or move the camera.
Okay, I'm trying to juggle me, the mouse, and the camera, for heaven's sake. So yeah, bear with me, please. Okay. Okay, welcome. Yeah, and notice we're starting with a what are you doing?
I only see the screen.
I like the title.
Yeah, okay. Rainbows, coronas, and the Heiligenschein, the beauty of atmospheric optics. Okay, and I should say I gave this talk. There was no hope of my giving Neil's talk this evening. I mean, I'm not even totally sure what it was about. I think I know he told me at one point, and I know it had to do with stars in Scorpius, and and that's a thrilling idea, and I'd love to do it, but I have absolutely no information, and he does. So I got home at 3:30. He wasn't feeling well, and he said, "Here, we're going to run with this." Those of you who have been around the club a while, I gave this talk originally back in the St. Francis era, actually. So this may not be new to anybody, but we'll see. Anyhow, we'll go on. All right, the dilemma in the Ainslie household, or it might have been the car. I didn't know when I put the talk together, and I sure don't know now. Okay. This the genesis of this talk was with a Friends of Wabache State Park thing. They were putting together a Hoosier Master Naturalist class, and the Hoosier Master Naturalist program, they're kind of open on what you can include as classes in this program. It's usually, I'm not sure of the length, it's usually a multi-day or multi-evening thing. And they encourage you to use local expertise, local talent when possible. And so we're organizing this thing, and Neil says, we've got to do something on astronomy. But then we're on our way home and we can't decide. And they've said, okay, this is great. And we can't decide what astronomy we want to do. Neil wanted to do a general astronomy class. And I thought atmospheric optics would be a lot more up people's, knowing atmospheric optics as I did, I thought it would be a lot more up people's, it'd be something that a general outdoorsy person would be more interested in. Well, he didn't agree with me, and this went on for several days, and eventually I found an image on the internet that kind of sealed it. So yeah. So he did do a little bit general astronomy, but the main focus of it was atmospheric optics. Let me see, what is atmospheric optics, and what do you care, and why should we care anyway? Well, here's my definition. At least this was my definition for the Master Naturalist people. Atmospheric optics is the subset of sky phenomena which normal people are most likely to stumble upon in their day-to-day activities. If you're an outdoorsy person, well, you'll see Jupiter maybe, but you won't know what it is unless you've got somebody that knows something about the sky. What you're gonna see that you can recognize is things like rainbows, halos, mirages, things like that. And atmospheric optics is kind of like where astronomy and meteorology meet and hold hands. is another way I describe it. This is the picture that I found, and I don't know if the audience out here in the student union can see it very well, but this came from the Atmospheric Optics website by Webb Cowley, website and blog by Les Cowley. He described this as possibly the first picture taken in the world, this was taken in Hungary, of a pollen corona, a corona around the sun caused by pollen. Let's see. I don't know if, oh, here we go. Yeah, the sun is off the screen this way, and look at the weird. Yeah, look at the weird corona here, and this is an image of one of the pollen grains that was causing this thing. This guy was out in the wood. This guy was just out in the woods with a smartphone, and did something that outdoorsy, woodsy people can and sometimes do. He kicked a ripe puffball. Ripe puffballs give off a lot of pollen grains, or not really not pollen, but spores. That's the word I'm looking for. Yeah, and the spores can be different shapes, and pollen can do this too. I have since then, I've seen coronas from pine pollen taken in the North Woods, and they're freaky too. In fact, I think they're usually, instead of being a ring around the sun or the moon or whatever, there's 4 spots because of the shape of the pollen. It's really strange. Anyway, trying to read my notes here. Anyway, this guy was walking in the woods in Hungary, kicked a puffball, and happened to see this corona, snapped a picture of it, and couldn't explain it, so he sent it to the Atmospheric Optics website. And this was a world first, and people caught on. People see them now, but he was the first one to see it. Puffball spores. Okay. Now, this is what got me into atmospheric optics. I was 18 actually. I had been reading astronomy books from the library, but I did not do any outdoorsy type outdoor astronomy whatsoever. And happened to see a sunset one time, and the sun, a wedge of the sun just disappeared. There was no cloud. There was no visible cloud or anything. Even when the sun was behind it, the sun just disappeared. I found out years later that this was probably a temperature inversion. The sun actually set through a temperature inversion. It's still one of the freakiest things I've ever seen in my life.
Near the horizon?
Sorry?
Wasn't near the horizon?
It was setting. It was near the horizon. It wasn't at the horizon. I think it was probably about 5 degrees up yet, but not much, 3 to 5 degrees. Anyway, mirages is a subset of atmospheric optics, which we're not going to go into too much in this talk, because mirages really ought to be their own talk, and I think somebody else should do it, because I don't really know anything about mirages apart from, have you ever seen a mirage at night? You know how when you're driving down the road during the day and you see you see what looks like water, or the sky is coming down on the ground in front of you? That happens at night also, but you have to have car lights or something like that to see it. Every so often on my way to work, this is one thing that's nice about going to work at 0 dark 30. I see these things now and then. Okay. So atmospheric optics includes mirages, auroras, once again, probably not something I'm going to go into too much. Rainbows. Sure. Halos and sundogs. This is actually a whole ice crystal display. Yeah.
What's a sundog?
The sundogs are these things right here. We'll talk a little more about them later in the talk. Okay. Crepuscular rays. I really like this picture. Crepuscular rays are what people call the sun drawing water. And you can kind of see these are the crepuscular rays here coming through the trees. Okay. And other cool stuff. See what's going on here. This is a full moon or nearly full moon. And gee, how do I know that this is a full moon? That's something we can learn. Okay. Now, I just skipped a page. Now, unfortunately, I discovered when I was putting together my slide set for this talk originally that sometimes you and Google just are not on the same page. They're just not on the same wavelength. When I was trying to get images of halos, Google kept giving me images of a certain video game. Can you imagine why? Yeah. Yeah, and the Heiligenschein, which we'll talk about later, for some reason, a fair number of the hits came from German language websites that were, shall we say, adult. I don't recommend Googling the Heiligenschein. I forget what it exactly meant, but yeah, I mean, anyway, so enough said. Oh yeah, and Corona. This was, yeah, and you know, searching for Corona, this was before coronavirus. I don't even want to know what Corona gets you now when you try to search it. But anyway, no, I don't, no. Speaking of which, no, I don't want Dalek love, my word. And I have no idea what this had to do with it anyway, but it came up. I'm going to go for breadth rather than depth because there's a lot of things to talk about, and we don't have that much time. And besides, I was talking to totally not, people that weren't really necessarily interested in the why this happens, except for maybe skimming over the surface. Anyway, also research is ongoing. To my knowledge, we still don't know what causes the 22.5 degree halo, the common halo around the sun and moon. People used to think they knew what it was and that it could only happen if the sun was below, I think it was about 40 some degrees in elevation. And then people started going on tropical vacations and coming home with pictures like this, which were much higher up than that. So research is still ongoing. There might be more than one thing that causes it. We don't know. I certainly don't know. So, okay, next slide. Scientists haven't figured out all this stuff yet. Well, you'll have to bear with some more hand waving here. We talk about the dual nature of light. Light behaves as waves and also behaves as particles depending upon the situation. And they say it definitely behaves as both, and that's the reason why you can see through a window and also see your reflection in the window at the same time, because waves work as the explanation for one, particles work as the explanation for the other. Anyway, dual nature of light, waves and particles. This is why we have refraction effects. The path of the light changes in different media. For example, rainbows. I thought somewhere there was a picture in here of a pencil, somebody stuck in water that did that bend thing. As it goes between air, as the light goes between air and water. But refraction effects are rainbows, halos, mirages. This one's hard to see, but I think this is a bridge being upside down in raindrops. Oh yeah, the bridge is in the background and raindrops on somebody's windshield. That's a neat image. Somebody was very observant on that one. And then diffraction effects, where the light waves are deformed. That gives you coronas around the sun and moon. There's a thing called glory. That's another thing you don't want to Google, please. And the Heiligenschein, which is kind of a subset of a glory. Okay. Now, it's not a perfect world. I mean, here we've got a rainbow with what they call supernumerary arcs, which, okay, the rainbow is caused by refraction, but then the supernumerary arcs in here, that kind of looks like a interference thing, doesn't it? And that's probably what it is. Anyway, this is the general idea. Okay, crepuscular rays we'll start with. Commonly known as the sun drawing water. We're back to this outdoorsy type scene. There's no refraction or diffraction here. It's just it's perspective. It's the same thing that causes, we've all been looking at the Perseid meteor shower, have we not? And you see the meteors going all different directions. Well, because they're coming from one particular place. And okay, these are all centered upon the sun and going off all different directions because we're looking toward the sun. It's kind of like looking down railroad tracks or something like that, where everything converges off in the distance. Yeah, the Earth shadow. I thought there was, okay, I'm surprised. I thought there was, shoot, can we go backwards? I honestly don't even know how. There's also a thing, and I'm surprised it isn't in here, called anticrepuscular rays, where these things, if they're strong enough, the crepuscular rays will converge on the anti-solar point, the point in the sky that is opposite the sun. And you can see them, usually just after sunset. And oftentimes in that thing we just saw, the Earth shadow, or which is sometimes called the twilight wedge. I've heard this called the zone of Venus, which is the dumbest name I've ever heard because this is opposite the sun. Venus cannot ever be seen here. The moon, yes, but Venus has to be close to this. Venus in the sky has to be close to the sun. And this is the opposite side, so that can't be. But some people call it the belt of Venus. So, okay, some people call things strange things. Anyway, the blue is the shadow of the Earth. And as the sun sets, this rises. And there's this reddish zone above it, which is essentially sunset, seen from the other side. Okay, now, where that other one was not a full moon, this is a full moon because it's right in the Earth shadow. Oh, here we go. I should have taken time to look at this closer before I got up here, but just didn't have time. Anyway, the anticrepuscular rays, these are often paired with crepuscular rays. And what causes them in the first place is clouds in the distance that you can't, they may be over the horizon, you can't see them, but their shadows blocking the sunlight can be seen and cause those anticrepuscular rays. The anti-solar point would be about right here, because they're all zooming in on that point.
So this is because the Earth is round or something?
Because the Earth is round.
Right, because the shadows couldn't come from off the plate.
Yeah. Yeah. Well, it's because of perspective. It's because of perspective, because when it's close to you, they look the broadest. When it's overhead, usually when it's overhead, crepuscular rays, anti-crepuscular rays aren't even visible because they're so spread out. But then when you get nearer to the horizon, either direction, they become more visible. Okay. Yeah, they meet at the anti-solar point. Notice on this one, the sun hasn't quite set, so they're converging on a spot that's below the horizon this time. Oh, seen from space. This is cool. We've got clouds, and maybe some of the people in the back can't see, but the clouds are casting shadows. And to somebody seeing them from beneath, they're going to look completely different. Are we good to go on? Does anybody need to get closer to see this? Okay. All right, we'll move on to rainbows, which is everybody's favorite thing, really. Although rainbows are difficult. I mean, you look at people's calendars and how did they do that? Well, mostly what they're doing is polarized filters on their cameras, because the light from rainbows is polarized. And when can we see a rainbow? Is that something that is that something everybody should know? When can you see a rainbow? Yeah, you have to have the sun less than 42 degrees high. You have to have rain on your head, or ideally rain on your head, and your shadow on the ground. Now, once in a while, I've seen them without rain on my head, but not very often. And your shadow on the ground. This is I'm not sure if this was taken from a tall building or if it was taken from an airplane, but it could have been either one, perhaps.
You don't see both ends of them real often.
Yeah. But this is the scenario. Rays from sun strike falling water droplets. The observer, the rainbow is centered on the anti-solar point, which is why the sun has to be less than 42 degrees high. Because otherwise the rainbow is going to be below ground level. That said, if you're in an airplane, you can see one. If you're in an airplane, you can see a rainbow you can see a rainbow anyway. Okay. Supernumerary arcs. In other words, these are the repeating purple and kind of blue-green, purple and blue-green that's on the inside of the typical rainbow. I haven't seen any of those for a while, but it's happened. Ed.
Going back to the previous thing, you didn't talk any much about the secondary and interior rainbow.
Yeah, we haven't got to that
Oh, you're
yet.
going to it, okay.
I believe that's coming.
But I had a question on that when you get to it there.
Yeah.
primary rainbow, the red is always on the outside, right? And the blue is on the inside.
Correct.
Is it the same on the secondary rainbow?
It's reversed on the second. Okay,
What about the Turner? Is
Yeah.
there like a triple rainbow you can see occasionally?
I never have. It's theoretically possible, but let's see. Okay, where the primary rainbow and the secondary rainbow are both in one direction, facing away from the sun. The tertiary, if I remember correctly, is way over your head. If I remember correctly.
That's where it starts.
Yeah,
But I don't know.
they've seen in laboratory experiments, they come up with multiple orders of rainbows. I forget how many, but lots. Like 10 to something like 10 to 15, 10 to the 15th order rainbow. And they all over the place after a while. Anyway, the mist bow, this thing looks to me more like Hellion Shine or something like that. But I have also seen the this particular one, I mean, but there is an actual mist bow as the size of a rainbow. And those are caused by really tiny raindrops. And one of the early, when I first got interested in atmospheric optics, one of the first rainbows I saw after that in a really rainy summer in 1988, I believe it was a red mist bow. The sun was setting at the time, red mist bow. And as the sun continued to set, the ends of this mist bow rose above the horizon, along with the twilight wedge. It was cool. It was really cool. If you ever have a chance, those are neat. And also a regular rainbow you can still see after sunset, but once again, the ends of the rainbow will rise along with the shadow of the earth, along with that twilight wedge. You probably won't see it for very long after sunset, but it can be done. Oh, and a sunset rainbow, you start to lose you lose the purple, you lose the blue. It becomes yellow, orange, red successively. Okay, we've got a mist bow here with a secondary. What? Well, this is what somebody called it. Notice this thing is very white. There's a little bit of color here, but mostly it's very white. And mist bows tend, when they're not being caused by a setting sun, a mist bow won't really have a lot of color to it. I've not seen, apart from that red mist bow, I've not seen very many of these. And this is the secondary, and boy, that thing's faint. I'm not sure how they even saw it in the sky, but anyway. Visible and infrared rainbows. This is something else I got off of the Les Cowley Atmospheric Optics website. Notice it continues. It continues. Yeah, there's infrared. Yeah, there's colors in the infrared in the rainbow that you can't see. This is neat. Very close rainbow from Spray. I actually saw that headed home on State Road 1 one time. It was not too long after 3:30 in the afternoon, which at that time I worked out 3:30 was about the earliest that you'd be able to see a rainbow. And so I'm sitting on the side of the road waiting for, just south of the 469 interchange, waiting for the rainbow to happen. And it's just rained. People are driving past, throwing water in the air with their tires. And wow, when it came up, yeah, there's a very close rainbow. It was cool. Okay. Snow rainbow. This is something else Google gave me. Why?
You can get rainbows too.
Yeah, this is lunar rainbow, or some people call these moonbows. These are hard to find except at certain places that will tell you all about that you can see these things here. geysers in certain waterfalls. I know there's one in Western Kentucky, I believe. I don't know too much about the geysers, but yeah.
It's kind of eastern Kentucky, but Cumberland
Oh,
Falls
Eastern. Okay.
is a place where people routinely try to see rainbows, and they do sometimes.
Yeah. Yeah, and I'm sure, I mean, I imagine where the moon, how easy it is to even see the bow depends on the time of year, because, you know, the moon's position at full moon is dramatically different from season to season. I mean, it'll be really far north when in the winter, and really far south in the fall. So, or sorry, in the summer. So yeah, I think this one's hard to see. This particular bow is hard to see, and it looks like a lot of it is more mist rather than a full color rainbow. But mist makes sense under the circumstances. More rainbows? Who do you think? Is that a rainbow? That is a sundog. Look, it looks like a piece of a rainbow in this case, but no, that's a sundog. These are technically called parhelia. Parhelia meaning close to the sun. And I guess they're also sometimes called mock suns, although I think the true mock sun is something different, but anyway. And moon dogs are also possible. I've seen them once. Moon dogs are really pretty rare. I think, well, no, I take that back. I think I've seen them twice. Don't see those very often at all. But the moon dog is a real thing, but it's a rare thing. And here's some more sundogs. And this is or what they call the common, or the 22-degree halo. You can see it around the sun or the moon. I think I've heard of I've heard of halos around Venus, but I think coronas are more common around Venus. But anyway, shoot, this does not look very large here. Let me give you an idea of how big the thing is in the sky. Your arm at arm's length. Do this. Hold your arm at arm's length. Put your thumb over the sun. Your pinky finger is probably going to be on top of the halo. So 2 of these things is at arm's length is the full halo. Yeah, this is not small. But it's not, yeah, but there are bigger ones. There are bigger ones. Partial halos you see pretty often. The 46-degree halo, which is of course twice that size. The 46-degree halo is also possible. This one you can see has, well, maybe you can see in the audience here, there's a bit of a color difference between the inside here of the halo and the outside. The inside's a little bit reddish, and the outside.
Trying to be a rainbow.
Yeah, it's there's a bit of refraction going on. It's mainly an interference thing, but refraction is trying to happen. Now, what causes well, no, we don't know what causes them. We know that it has something to do with ice crystals, but we don't know for certain at the moment. Ice crystals and clouds. We don't know for certain at the moment. These are ice crystal displays. And one of the best places to see them is at, of all things, ski resorts. Ski resorts tend to have, you have a lot of blowing snow, and especially if it's artificial snow, it tends to be crystals that are all about the same size. So they're whatever internal reflection or refraction effects really add up. So we've got some crazy things going on here. These are of course our sundogs. I always call it a sundog with a tail. but the tails are part of, shoot. I forget what the, I forget what the name of it is. I want to say the Parhelic Circle, but I'm probably wrong. This is the 22-degree halo, 46-degree halo, subsun. There's periarcs. Oh, there's some other weird things going on here. I actually saw a chunk of this thing here one time and couldn't have done it. And it took me a long time to figure out what it even was because I couldn't see most of the rest of the ice crystal display, but there was that thing, plain as day. Okay. Now, and the circumzenithal arc is this thing right here. The same ice crystals which create sundogs also cause the circumzenithal arc. And the circumzenithal arc, that's something to look out, that's something to look out for because it's the best rainbow of all. It's much more colorful than most normal rainbows. And it's right overhead. It's generally right overhead. And a lot of people aren't even looking. I mean, I've seen people walking around and don't even see it because it's way high overhead. You've got to basically crane your neck to see this thing. But if you're seeing sundogs, take a glance and see if there's a circumzenithal arc up there because it could happen. They're apparently caused by the same kind of ice crystals, with the lights just taking a different path through it. And why is this thing seen so seldom? Probably because it's just so far overhead. Okay, auroras. Like ice crystal displays, these are most often seen in polar regions, but as we get closer to solar maximum, we might see auroras descending to our area at some point here in the next few years. I'm certainly hoping for it because there's some cool things going on. And here's the, and remember I said there's still research going on in this. This talk is so old that we don't even have anything about Steve in it. Steve is a acronym for, I forget what, STEVE. And it's not actually an aurora, but it appears along with auroras sometimes, usually with the picket fence type. And I've not ever seen it, but I've seen pictures. They are pretty cool. The pictures are anyway. This was billed as an aurora, but I think this is actually sky glow. This green here. But anyway. Yeah, auroral storms which are only seen around here during solar maximum. There was a amazing auroral storm when Neil and I were engaged over 30 years ago. And I would dearly love to see one of those again. I mean, it wasn't just clouds. It didn't just look like kind of a cloud hanging in the north. There was actual activity and movement going on. It was almost like at one point, it was almost like there was a curtain rippling in the sky. Really neat. Okay, we will go on to coronas, which are, you see them in thin or broken water clouds. People that do mirror testing, you remember the airy disk? That's essentially what this is, except it's around the sun or the moon. And the corona has colored clouds, as you can see. There's kind of yellowish white. There's a reddish brown here, and almost a bit of a bluish hint to the outside. And the name, of course, comes from the Latin word for crown. And boy, that really looks like an airy disk, that one. And remember the puffball corona from the beginning of this thing? No, this is something else. Oh, glory. No, this is not a glory, for heaven's sakes. Who thought that? Ugh, no. That is more like it. Glories are seen from mountains or tall buildings or airplanes. Where do you think the person was sitting in this particular airplane? I don't think they were in the front. I think they were back about right here. They're shooting out the window at the shadow of the airplane on the cloud below them, and there's the glory around them. And the shadow may or may not be seen within the glory. I think this might actually be a shadow, but it's hard to tell. Now, this version is also called the specter of the Brocken. This is somebody standing on, I don't know if it's a mountaintop or what, but somebody standing there taking a picture of this thing, and boy, your legs look gigantic and your head looks tiny. And lastly, ever seen that? We used to see these things back in the Fox Island days. We used to see this every so often on full moon nights. The hill had grass on the sides, and when there was a heavy dew, you could actually see this around your head, this glow around your head. This is a version of what we call an opposition effect. This is the Halligan shine, or the translation is holy light. And it's named for its resemblance to these things, for heaven's sakes. Sorry to be postmodern here, but it doesn't have anything to do with, you know, it's not you. It has nothing to do with you. Somebody's holding their camera off to the side, and look, the Halligan shines around the camera. And oh yeah, put the camera on a tripod and you see it there too. It has nothing to do with you. Sorry. So now we've got some Halligan shine, and it looks like we've got some anti-crepuscular rays here. Cool. Any questions? This is, of course, an eclipse. This has nothing to do with atmospheric optics. It just, it must have just appealed to me at the time when I was putting this together. All right. Has anybody got any questions? I'll try and answer them. Yeah, if you got any questions, I'll try and answer them. Well, although we've already had some questions, so, okay.
I'm not pronouncing this correctly. I'm not sure how you pronounce it. Occlusive clouds fit into this atmospheric optics?
Sorry? I'm sorry.
You're going to force me to say it even.
Yes, I know. Isn't that awful?
Occlusant?
Naclucent?
However it is actually.
Naclucent clouds?
Yes.
I don't know. Actually, I think it could.
Dust or some other.
Yeah, it's yeah. If I remember correctly, it's meteor dust in meteor dust in a bit of maybe a bit of water in the extreme upper atmosphere.
But you don't cover them, so.
But yeah, Naclucent is night shining. Because they're the last clouds that go away after sunset. I mean, you can see them long after sunset or long before sunrise. That's something that, yeah, this is something else I'd like to see sometime. And I don't know, this could happen because they're the Naclucent cloud thing is still, it seems to still be growing. So, yeah. Okay. Any more questions?
You were talking about halos, the
Yeah.
22 degrees and 46 degrees. Was that how do you define that angle? Is that like the sun angle above the horizon, or
it's the it's the diameter of the
radius?
radius. Yeah.
Okay.
It's
Oh, so
radius.
it's the
It's the
sky-
radius. Yeah, it's the radius. Yeah, it's
and the sky.
yeah, it's
Okay.
radius in the sky from the sun to
From the
the,
sun's position to.
the sun's halo itself.
Okay,
Yeah, so the 46-degree halo basically covers half the sky.
okay.
And the 22-degree halo is not small either. All right. We done? Well, I think I'm done, so.
Thank you.
Great, thank you.